Welcome everyone. Thank you for joining us for today's webinar. My name is Igor Seletsky and I am the CEO and founder of Cloud Linux. Cloud Linux team is the name behind a range of tools helping enterprise companies to keep their Linux-based system secure, stable, and profitable. Today, we are presenting the importance of live patching for Linux kernel vulnerabilities, presented by Tariq Hassan, Unix and Linux System Administrator at Affinity Waters UK, Claudia Morales, Partner Solution Architect at AWS, Jamie Charleston, Senior Sales Engineer at Cloud Linux, and hosted by me, Igor Seletsky, CEO and Founder at Cloud Linux. During the webinar, you will learn the best practices of securing the highly sensitive infrastructure of public utilities from security breaches with KernelCare. Learn more about fundamental concepts in AWS Security, see how KernelCare protects servers from vulnerabilities, get your questions answered by Cloud Linux and AWS experts during live Q&A session. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel or post a question on Twitter with the AWS KernelCare hashtag. I'll bring them up for the Q&A session at the end. Note that the webinar will be recorded. If you do not want to participate in the recorded webinar, please leave now. Now, without further ado, we will turn the time over to Tariq Hassan from Affinity Water UK. Tariq will share the best practices of how they use KernelCare at Affinity Water to defend their business from security breaches.
Hello everyone. My name is Tariq Hassan, and I'm a Unix and Linux systems administrator at Affinity Water in the UK. With a long history dating back to the 1880s, we're now the largest water-only utility in the country, operating mainly in the southeast of England and parts of London. We supply a population of 3.6 million people with 900 million litres of water every day. That's roughly 240 million gallons, or 360 Olympic-sized swimming pools. You can probably imagine that we use our computer systems for such things as storage, filtering and decontamination, quality control, demand planning, distribution and logistics, metering, billing, a lot of different applications. Of course, they all have to work without fail 24 hours a day, 365 days a year. I've been in IT for 25 years, and I consider myself a hardcore Unix guy. I got into Linux about 5 years ago, and here at Affinity Water, we have around 100 Linux instances, some in the cloud in AWS, and some on-premise VMs. They are a mix of the usual suspects: Red Hat, Oracle, Ubuntu, and Amazon. People say there's not much difference between Unix and Linux, but the rate of development is different, especially in the kernel. Unix is closed source, so the rate of change is slower. But it's also been around a lot longer, so it's had more time to stabilize. What that means in practice is that the Unix kernel gets updated maybe once or twice a year. On Linux, it can be once a month, if it's going through a bad patch. So if you ask me which of the two I prefer, I'd have to go with Unix, purely from a sysadmin point of view. Lately, Linux seems to need more admin work, but that's not the biggest problem. With Linux, the biggest problem for me is downtime, and I expect some of you know why, but for those that don't, here it is. Whenever a new Linux kernel patch comes out, it means a reboot, and for the systems here at Affinity Water, that's especially painful. In this industry, and many others like it, there's no way we can just bounce an instance when we feel like it. It has to be scheduled in. There has to be lots of planning, lots of haggling with other departments, emails back and forth. I'm sure you know what I mean. Plus, there's all the documentation and management reports. For most of us, it's just a nightmare. Unfortunately, with Linux, reboots are unavoidable. It's an open source kernel, so it's always changing, and there's a constant stream of bugs being found. Now, don't get me wrong, I'm not against finding bugs, but there are bugs, And then there are vulnerabilities, and vulnerabilities make me nervous. In contrast to Linux, Unix is closed source and proprietary, so only the vendor can see the source. A Unix vendor will fix a bug and then tell you what it was. In the Linux world, it works the other way around. Anyone can find a bug, and when they do, straight away they publish it for everyone to see. Sometimes they even explain how it works and how to exploit it. In one sense, this is great, because the more people that know about the bug, the quicker it gets fixed. But in this situation, the cat's out of the bag, so to speak. You, me, anyone who's running an affected server, we're like sitting ducks, waiting for fixes and hoping we can install them quickly. That time delay, the gap from announcement of a bug to the patching of a bug, that's what they call the vulnerability gap. Okay, sure, with most vulnerabilities the risk of being a target is small, but for us even a small risk is too much, and I'll tell you why. I think we all realise that hackers, well most of them anyway, all they want is to grab data and turn it into money. If not that, then they want to hijack servers and use extortion to make money. But for us in this business, there's another type of threat to think about, a more sinister one. These are the hackers who don't want data or money, they only want to cause damage and mayhem. So here at Affinity Water, we're all keenly aware of the importance of cybersecurity. We have to take it seriously, and we have to show that we do. We're in the public eye, and we have to think about public safety, not just about profit. So, back to that so-called vulnerability gap on Linux. The question was, how do we keep our Linux servers patched and safe without shutting them down? Well, we found the answer, and I'm going to tell you about it right now. It's called live patching. I only found out about it a few months ago. It's a way of updating a Linux kernel without stopping it. In other words, you don't have to reboot the server it's running on. That bit about not rebooting was what caught my eye. At first I was thinking, if we could ditch some sysadmin work, we'd save some hassle, and I might get a little bonus if we save money as well. But the more I thought about it, the more I saw it in a different light. I started to think of live patching as a sort of security boost, in the sense that it shrinks the vulnerability gap I was talking about. Usually we'd wait weeks, sometimes longer, before we could organise a maintenance window for installing kernel updates. If I understood the concept of live patching correctly, critical patches get installed immediately. We wouldn't have to wait at all. No planning and no downtime. So, I started looking around at the different live patching services out there. Apart from the price, they all seem to do the same basic thing. You only see the differences when you dig a bit deeper. And as I said, we have a mix of Linux distros, so I wanted something that could run on all of them. I didn't really want to mess about with separate contracts with different vendors, and I didn't want to learn different tools. KernelCare was the only one that ran on all our distros, and we didn't have to cough up for extra support, something we didn't need and weren't going to use. We just wanted the patching service. So we tried it on one of our boxes. It was dead simple to set up, and the help desk was good too. They seemed to know their stuff. I didn't have to wait ages to hear back from them. We tested it thoroughly, and it all worked fine. KernelCare's patch turnaround time is excellent, but the big plus point for us is their patch rollback facility. That means, if there's any doubts a patch has affected performance or stability, we can back it out and run some more tests. So, fast forward to now, and we've got KernelCare running on all our Linux instances. Management is happy because less downtime means we don't have to apologise to anyone. The compliance people are happy because we're safer, and our systems are always up to date with regards to security. And for myself, I've managed to get back a bit more of my personal life. I do less weekend work and hardly any all-nighters. So, that's it. Thanks for listening. I hope you got something from this. But let me just sum up. Getting KernelCare wasn't only about making life easier. For sure, it did that. But it solved a bigger problem. What it solved was this: how to stop choosing between security and uptime. System managers shouldn't have to face that dilemma, because these days, none of us can allow cracks in our security profiles. We've got to keep our eyes open all the time, and always be on the lookout for incremental improvements. So once again, thanks for listening, and have a great day wherever you are.
Thank you, Tariq. Now, Claudia Morales, Partner Solution Architect at AWS, will cover fundamental concepts in AWS security and best practices.
Hello, everyone. My name is Claudine Morales. I'm a Partner Solutions Architect at Amazon Web Services based in Seattle. First of all, I'd like to thank the team at Cloud Linux, who is an AWS Partner Network Advanced Technology Partner, for inviting me to be a part of today's webinar. For my presentation today, I'm going to cover some fundamental concepts in AWS security, as well as some general best practices. I'd like to start by saying that at AWS, security is job zero. It will always be our top priority, and that's true to our internal culture as an organization where every employee is responsible for upholding security standards in their day to day and is empowered to report and escalate security issues if needed. And that is also true to the extensive security technologies that we offer our customers as a cloud provider. We have a team of world class experts who are entirely dedicated to helping our customers secure their data in the cloud. We have over a decade of experience supporting millions of active users per month, and these are customers all over the world, businesses of varying sizes running every imaginable use case. We have been able to establish best practices around security that have been validated not just by the security experts on our customers' end, but also security auditors around the world. To respond to the compliance requirements of our most demanding customers, we have worked to achieve compliance with many certification and accreditation programs, including global programs such as PCI DSS, SOC 1, SOC 2, SOC 3. We're compliant with US government wide programs like NIST, FedRAMP, FISMA, and a number of assurance programs that are recognized in Asia Pacific and Europe as well. Because we manage these programs in our infrastructure, we can help you more easily meet your compliance requirements. If you have any compliance requirements for your workload or want to know more about our compliance programs, visit the AWS compliance page, which you can see on your screen right here. Our customers benefit from the best practices in our policies, data center and network architecture, and operational processes that we have built to satisfy the needs of our most security sensitive customers. Our security technologies also scale with you, so no matter how big your business grows on AWS, you really are inheriting these best practices that we have built. Not only that, but we can help you save on costs as well because we do a lot of the heavy lifting for you in many areas, which takes away the need for you to spend money on managing those components. I am going to touch on some of those components as I go through the rest of this presentation. That said, I'd like to tell you something important about how we view security on AWS. The fact is, AWS alone cannot achieve all of your security and compliance objectives. It is a shared responsibility. AWS controls and manages certain components, but you as a customer have to do your part. And this is why it's great that you guys are listening in today to learn more about KernelCare and the benefits it offers when it comes to managing the security of your Amazon Elastic Compute Cloud or EC2 instances that you have running on AWS. You have your share of duties to protect your AWS environment. To break that concept down, the AWS shared responsibility model defines who is responsible for securing which components. The orange layers are what AWS has access to and what AWS controls and manages. We refer to that portion as security of the cloud. So this includes our global infrastructure, meaning AWS regions, which are geographic locations where we cluster our data centers, our availability zones, which are the clusters of data centers that we have within a particular AWS region, and our edge locations. Edge locations are what Amazon CloudFront, which is our content delivery network service, uses to deliver content to end users across the globe with lower latencies. Today, the AWS cloud spans 64 availability zones across 21 geographic regions around the world, and our global network of edge locations consists of 166 points of presence with 155 edge locations and 11 regional edge caches in 65 cities across 29 countries. AWS is also responsible for designing and building our services securely. The blue layers, on the other hand, are what the customer has access to and what they control and manage. So that is your security in the cloud. This includes selecting which services you use, building your application securely, defining who or what gets access to which resources in your AWS infrastructure, what data you store, and where you store that data. This also includes how you encrypt that data. You are always in full control and ownership of your data on AWS. We offer a huge set of services and features to help you with your encryption needs for data at rest or data in transit. Services like AWS Key Management Service and AWS Cloud HSM enable you to create and manage encryption keys that you can use to protect your data on AWS. Now, AWS does not have access into the customer account, the blue part, and the customer does not have access into the underlying part, which are the orange layers. And I thought that was very important to point out. So, digging further into that shared responsibility model, AWS is responsible for the security of the host operating system down to the virtualization layer. We also take care of the physical security of our data centers. Our data centers are highly secure by design. Our process for selecting our data center locations involves many, many hours of analyzing potential threats and designing necessary controls to mitigate risk. Our availability zones are designed to have redundant power feeds to withstand power outages, and they are built to be independent and physically separated from each other so that we can reduce the risk from potential environmental events such as earthquakes, flooding, or extreme weather conditions. We have professional security staff at all entry points of our data centers, and access is granted only to authorized personnel who are restricted to the specific layers of the data center that they need access to, and only for the amount of time that they need access. We have surveillance and detection systems in place to monitor, detect, and alert on security incidents. As an AWS customer, you can leverage our highly secure data centers and you can save on costs as well, since you don't have to manage any of that. So, now what do you have to do as a customer to help protect your data in the cloud? The answer is it really depends on the AWS services that you choose to consume. But let's talk about Amazon EC2 instances. As I've mentioned earlier, AWS does not have access into the EC2 instances that you are running. You are responsible for securing the guest operating system. That includes proper access. You should limit access to and from your EC2 instances based on the principle of least privilege. AWS Identity and Access Management, or IAM, is a service provided to you free of charge that allows you to apply fine grained access controls to your resources. But you have to define those configurations. You have full control over your IAM policies. That also includes security group configurations. Security groups act like firewalls that control inbound and outbound traffic for your EC2 instances. As best practice, you should think least access when defining your security groups. Only open ports that need to be open. Maybe don't expose your database to the public internet. You are also responsible for software updates and security patches, which is why we're doing this webinar today. There's a lot of malware out there designed to capitalize on known security flaws in your software or your operating system, and as best practice, you should be applying updates and patches immediately when they're available, and you should know if you're missing any patches. The security experts at KernelCare will have a ton more information for you on this topic. But I'd like to point out that this shared security model is beneficial for our customers because you get the flexibility that you need to deploy applications with your desired configurations while being able to rely on AWS to do the heavy lifting in many areas. You can leverage the many security services, features, and compliance programs that we have so that you can have more time to focus on innovating and building the products that really differentiate your organization. So I've mentioned some of the security components that you as the customer need to manage when using Amazon EC2 as part of the shared responsibility model, but I'd like to share some more general best practices that will help you better secure the EC2 instances that you are running on AWS. And I've already covered best practices around access and privilege in the previous slide, but it's also best practice to have a baseline for your EC2 security configuration and use that baseline to assess every EC2 instance that you have running in your environment. You should have logging enabled on all of your EC2 instances that you are running so that you can collect configuration data on each of them. This allows you to flag and act on any deviations from your baseline. It's also a good idea to implement a change management strategy for rolling out necessary changes on your EC2 fleet, including changes to security groups, configuration changes for applications you have running in your EC2 instances, software upgrades, patching. It's also critical that you have some sort of audit logging mechanism in place to track the changes done on your AWS environment. You can use AWS CloudTrail to track many of the activities across your AWS account and AWS Config to monitor and evaluate configurations for your AWS resources. AWS offers a robust suite of security services and features that can help you meet your security objectives. We also work very closely with our vibrant community of AWS Partner Network partners who offer hundreds of tools and features such as KernelCare to help you better secure your applications in the cloud. I'd like to encourage you to learn more about the AWS shared responsibility model and download the AWS Security Best Practices white paper using the respective links that you see on your screen. I hope this was helpful. Thank you again to the Cloud Linux team for having me here today, and thank you everyone for joining.
Thank you, Claudia. Just as a reminder, please be sure to type your questions into the question box in your control panel or post a question on Twitter with the AWS KernelCare hashtag. Now is the time for Jamie Charleston, Senior Sales Engineer at Cloud Linux, show how KernelCare ensures your servers secure in live mode.
Hello, my name is Jamie Charleston. I'm the Senior Sales Engineer with KernelCare. I'll be sharing an overview presentation and demo of KernelCare with you over the next several minutes. So let's get started. KernelCare is live Linux vulnerability patching with no reboots, ever, powering over 280,000 servers and trusted by over 1,500 enterprises. So what is the problem with rebooting? For servers to be secure, kernels must be up to date. This requires frequent updates and reboots. Unpatched kernels make servers vulnerable to attacks. Enterprises often wait weeks or even months until the next reboot cycle to reboot the servers, and delays lead to compliance issues and critical security risks. And what can KernelCare do to help? Well, no waiting, no reboots. We eliminate downtime. We install patches to live or staging servers without performance impact or downtime. You never miss that critical patch. Our security team is monitoring all of the CVEs for security-related issues and patches. We generate those patches and then we release them to our distribution server. The agent checks for new patches every 4 hours. And it couldn't be any simpler. Single-line rebootless installation. It's just a few minutes for install, registration, and installing the patches, all to your live server without reboot. And as I stated earlier, we support over 1,500 companies, including Dell, Endurance, Liquid Web, to keep their servers on and secure with KernelCare. We have support for the most popular Linux distributions. KernelCare supports automatic updates or managed updates in live environments or your desired staging environments. Works on typical servers as well as virtual environments. We support Amazon Linux 1 and 2, CentOS, Red Hat Enterprise Linux, Cloud Linux. We've got Oracle and Enterprise Oracle, Debian, Ubuntu, and so on. The list is growing. So how does KernelCare work? Our security experts, who have deep knowledge of kernel development, monitor all of the different Linux security lists 24/7, 365. Many of these lists under NDA. Once they notice there's a vulnerability that affects supported kernels, they promptly prepare a security patch. This patch is compiled in a binary format and is deployed out to our KernelCare distribution servers. From there, your servers that have KernelCare installed have an agent that checks for new patches every 4 hours, and if found, it downloads it and applies the patch live in memory again without reboot. We protect against all of the different security vulnerabilities, especially those heavy vulnerabilities like Dirty Cow, Meltdown, and Spectre. Now what we have here is a standard Amazon Linux 2 EC2 instance. Now this particular instance has a very old Amazon Linux 2 kernel. So the first thing I'm going to do is do a uname -a, and I'm going to show you the actual kernel that this system booted with. It's the 4.14-3359. Now, the next thing I'm going to do is check for compatibility. And we see that this is compatible with our KernelCare product. So next, I'm going to sudo to root, and then I'm going to run our one-line command to install KernelCare. And you can see the process is extremely fast. KernelCare is installed, so next we're going to look at the license. And we can see that we've registered against our CLN portal. I'm going to clear it, and now let's look at the installation. Here's our uname. This is the boot kernel. And now with our kcarectl-uname, we can see the actual effective kernel. So we've live patched. This is a list of all of the patches that have been applied. We're able to see the CVE information on the patch that was applied, and we can also look at a URL where we can actually go to read more information on the specific patch. We'll clear the screen. And next we'll unload. This is how simple it is to remove all of those patches if you need to get back to the original boot kernel. Here's the uname of the boot kernel and the effective kernel. You can see that they match and they're both back to original. Let's clear the screen. And next we'll go ahead and reload all of those patches. And that fast, the patches are reapplied and you're secure again. Notice that we're doing all of this without having to reboot the server at all. And the final part of my demo is showing you the different interfaces that can be utilized. Now, for partners that are utilizing servers that have access to the internet, you can utilize our standard patch portal. From there, to manage your individual servers and manage your licenses, you can log into our Cloud Linux network portal. So I'm going to go ahead and log in. We have multiple products, but for KernelCare, we can easily select on KernelCare. And here you can see we have our general activation key. We can generate new keys. We can manage our different servers that are in our list, selecting on those and seeing registration and additional information. We also have the ability to submit support tickets off to our support team and manage our overall support center. Now, for those individual organizations that have servers that have a gap, they're behind a firewall, they don't want to utilize a proxy to allow the servers to access the internet, and they're keeping a very secure infrastructure, they can utilize our ePortal system. The ePortal system does require that you have a lightweight server within your infrastructure that's going to act as the repository of all of the kernel patches. Now, inside this infrastructure environment, this portal, you're going to be able to manage all the different types of licenses that you want to use, being able to also create additional licenses. This gives you the ability to control segregation of licenses for different types of infrastructure or different staging and production environments. You also have the ability to control the feed. The feed is all of the patches that have been synchronized between our patch server and your ePortal system, and gives you the opportunity to check out and work through the patches before you actually release them into staging or production environments. So coming through here, you can see I have 4 new patches that I haven't released to my downline servers. I can easily select on deploy the patch and all before it. It'll synchronize those in and it'll make them available. So when the servers call back to the ePortal on their 4-hour synchronization path, it'll check, it'll validate, and it'll download and install those. I can also go in and see more structure and more information related to the servers in my infrastructure. I can see their IP address, their host name, and the effective kernel. I can see when they were actually registered and the last time they checked in. I can go a little bit deeper into those individual servers, and again, the information that I had available from the previous screen, but also coming in and seeing more specifics. The distribution version, the distro itself, the type of machine, processor, and the actual original boot kernel. So, no matter if you are a small company or a large enterprise, have public-facing servers or a large data center footprint with secure networks with no internet access, we are the solution to keep your server kernels patched, up to date, and secure, without reboot for years, saving you time and money, all while keeping you compliant and secure. That was my portion of the webinar. Thank you very much for your time.
Thank you, Jamie. We will go ahead and take the rest of the webinar for questions now. Please be sure to type your questions into the question box in your control panel or post a question on Twitter with the AWS KernelCare hashtag. Okay, we have a first question. How is KernelCare different from Ksplice and LivePatch? So the technology is the same, it's very similar, but as implementation is different, we can actually patch more kernels, we can patch more vulnerabilities, and our patches are smaller, meaning that they take less memory overall. Another question, what are the examples of things that KernelCare can patch and the other technologies cannot? Just to name a few examples, it's Spectre Meltdown. Overall, we've been able to patch everything that came out in the past 10 years. So we actually have support for kernels that are 10 years old. We will patch all the security vulnerabilities for them. Never reboot is a long time. Even a year or more sounds too good to be true. How is this possible? We only patch security vulnerabilities, so the actual number of patches that we do is still manageable. It does get into hundreds of patches over 3 to 5 years period, but so far we were able to do that. We've been doing it for 5 years, and we actually have customers with systems who have not been rebooted since then. Does KernelCare releases patches for all old kernels? So yeah, we do release patches for all kernels. We support kernels that are 10 years old. We support CentOS 6. We actually can patch Red Hat 5, Red Hat CentOS 5 kernels as well. So once it stops being supported by vendors, we typically stop support for the kernel as well. Amazon has Linux AMI with its own security center. I recall Linux AMI Security Center patches some CVEs. Does KernelCare do the same? So AWS team does terrific work at maintaining security, and Amazon Linux team also does that, and they patch everything that needs to be patched. But if it is a kernel vulnerability, after it's patched, you still need to reboot the server for it to apply, unless you use KernelCare. So for Amazon Linux, the only way to update Linux kernel against security vulnerabilities without rebooting is to use KernelCare. We are behind the firewall. How do we pull the patches then? So KernelCare provides several modes of iteration. One is where your servers are directly connected to internet. Another one, you can go through your internal proxies to get all the patches. But will also allow you to set up an ePortal. That's our system that's done specifically for the cases where your servers cannot go outside of the firewall, even through the proxy. So you would install that server inside your firewall perimeter and serve all the patches from that server. So your servers never connect outside the internet.